Hello everyone. So from here on in this integration by substitution video series, I'm gonna solve tricky integration by substitution problems. Okay, so it's going to be exercise 6 problems in my note. Now, why do I call them tricky? Maybe we have to use algebraic tricks to solve these problems. Or maybe you will not see the inside function right away in these problems. Or even though you recognize the inside function, you know one thing from this video series, which is that not only inside function, its derivative also should exist somewhere else in the integral to be confident in using integration by substitution, right? So maybe you don't see that derivative explicitly. So we're going to address questions that has those type of problems. Okay, all right, so let's get on. Now first one is not very tricky. Now this problem, the only hesitant that we have here is that we cannot identify an inside function, right? The literal meaning of an inside function. Do you see some kind of an inside function? No. Well, you might think that this x sort of inside natural log x. So is x the inside function? Well, no. Here, even though we don't see it like an inside function right away, but we can say our u to be natural log x. Now, why is that? Several reasons. Now think about the derivative of natural log x. What is it? It's 1 over x. Do we have 1 over x somewhere else? Definitely we have 1 over x, right? This is not x, it's 1 over x. So for that reason, because we have that function and its derivative together in the same integral, because that we have that relationship, well, we can say yes, we can use integration by substitution here. Now one more thing. Natural log x is an inside function. The only problem here is that you don't see it explicitly right away, because look at this whole function, this whole thing here. It's a fraction, right? It's 5 over x natural log x. So fraction, you can think it like the big outer function, okay, outer operation. And now inside the fraction, in the denominator, you have natural log x. So in that sense, natural log x is inside the fraction, part of that fraction, right? So you can think it in that terms. Anyway, so u is natural log x. So du over dx, that is the next thing we want to do. Take the derivative, which is 1 over x. Okay. Now we want to make dx subject. So out from here, dx is actually, if you take x to the other side, be careful, it's x du, right? Okay, now we have two things that we need for our substitution. Then let's substitute. So 5 over x natural log x is u, dx is x du. Now you can see, we can see the cancellation by ourselves. So we are on the correct path. So we have 5 over u to integrate with respect to u. So we can take that 5 out. So we need to integrate 1 over u, which we get 5. If you integrate u, it's 1 over u, you will get natural log absolute value of u plus c. So let's finish the answer by writing, well, what is u? U is natural log x, right? So this is natural log x. All right, so this is our solution for this integral. It's not tricky, it's just we didn't see the inside function right away. Now be with me, I'm gonna solve really tricky problems. Okay, in every problem there's something to learn. All right, so let's look at the second problem, 1 over similar type of a one. So let me help you a little bit here. I'm not going to finish this one, but I'm going to help you, because after this problem I'm gonna do really interesting problems. All right, so here, what is the inside function? Here, going based on the name inside function, you can choose u to be your inside function, which is natural log x, right? Natural log x to be your inside function, not u. U is natural log x. Sorry, I said the wrong thing there. Okay, so what is the derivative of u? Well, derivative of u is 1 over x, and we do have 1 over x somewhere else in the integral. So du over dx is 1 over x, then dx is x du. All right, now if I replace them, if I substitute both these things into the integral, well, we have 1 over x, natural square root of natural log x, natural log x is u. Okay, dx is x du. All right, so x cancel out. Now what you want to do is you want to integrate 1 over square root u with respect to u. All right, so I will let you do this by yourself. The hint is we can write 1 over square root u as u to the half. In the denominator you can write u to the half. We can bring that to the numerator by writing u to the negative half, right? So I will let you solve the problem from here. Okay, it was not a hard problem. Now here's a tricky one. Here's a really tricky problem. This problem comes with a trick. Okay, identifying the inside function is not a problem. So what is your u? Guess it. Give it a try. What is u? Inside function, so it seems to be like x plus 1 is inside the square root and square root is inside the fraction. But let's be more specific, and the inside function choice is going to be x plus 1, right? Because that's the easiest. Okay. Now, here's the problem. Now, the derivative of x plus 1 is a constant. Do you have a constant somewhere else in the integral? Well, yes, constant can appear everywhere, anywhere, right? So we don't care about a constant. So probably we are fine here. Now, let me show you the trick, the problem here. Not the trick. So derivative of u is actually derivative of x plus 1 is 1. So dx is really du. Let's write the integral. So integral is x over, this is u, square root of u, dx is du. Okay. Now we didn't get to cancel a term here. That is why really we left with this x, right? Okay, because that cancellation, usually that simplification that leads to a cancellation, just like here in this previous problem, really usually help us to get rid of these excess terms. But really what happened here? Think it hard. Understanding this correctly will help you to do lots of problems correct. Now, what is the problem here? Why are we not able to cancel x here, get rid of x here right away? Because derivative of x plus 1 is not x. That's the problem, right? Okay, if it was x, then we could have cancelled it. So does that mean that our inside function wrong? Well, do we have another choice for inside function and inside function? Not really, right? And what's going on here? So that means we can't use integration by substitution probably, right? No, we can use integration by substitution here. The trick is whenever you cannot cancel out terms like here, or whenever you have excess terms. Now why do I say that I have excess terms? Because my whole goal in integration by substitution is to convert the integral that is in terms of x to an integral in terms of u. Now when I do that conversion, I cannot have mixed variables. Like here I have both x and u. That's wrong. That's not correct. You cannot afford to have that. Either you have to have everything in terms of u or in terms of x. That means you are in the place that you started. So you have to have everything from u. But here, unfortunately, we have x. Now, if we cannot cancel out, how can we get rid of that x? Your help should come from the substitution itself. Remember that always. Whenever you are left with excess terms that you cannot cancel and you have mixed variables and you have an x that you need to convert to u, it not need to be x, it could be something to do with x, could be x squared, could be x cubed, could be some kind of a function term that has to do something with x and you want to convert it into u, or you should have cancelled it but it didn't cancel. Where should you go back? You should go back to your substitution. Always remember that. Now why is that? Can we try to say x in terms of u? Definitely yes, right? What is x based on this expression? X is u minus 1. We just tweak this substitute a little bit. Alright, so x is u minus 1. Okay. Now we have everything in terms of u, don't we? Yes, so this is a one trick. What is the trick? Whenever you were not capable of getting rid of excess terms like here, that means whenever you are not able to cancel something when you're doing integration by substitution, then you are left with x term, something to do with x. If you want to remove that, definitely you want to remove that. If you want to do integration by substitution, what you do is you go back to your substitution where you define your substitution. U is equal to x plus 1. Try to write this excess term in terms of u with the help of this. Here we were able to do it very easily. We'll do more problems, similar problems in future, okay, in future video. All right, I did a lot of talking, but I'm sorry. I wanted to introduce to this new trick very slowly, okay? All right, now what can we do here from here? What can we do from here? That's the correct way to put it. Well, it's look even more complicated than what we started, right? But can we integrate this using basic integration? That's the whole point of integration by substitution, right? Well, we can do something here. We learn a trick under basic integration review video series, which is we can divide each term in the numerator by denominator. So we can write this as u over square root u minus 1 over square root u. Okay, now here furthermore we can simplify u over square root u is square root u, right? Okay, or you can think this as we have u over u to the half, square root u is u to the half. If we take this u to the half, this is u times u to the half, negative half. I'm sorry, when you take that term to the numerator it becomes negative power. So 1, when based on power rules you add these two, so 1 plus negative half is u to the half. So that is why I get u to the half or square root u. So let's write it as u to the half. U to the half. So here we can write this is u to the half, take it to the numerator, so it's u to the negative half. Now if you integrate with respect to u, this becomes u to the half plus 1 divided by half plus 1. Here u to the negative half plus 1 divided by negative half plus 1 plus arbitrary constant c. Alright, half plus 1 is 3 over 2 divided by 3 over 2 minus here negative half plus 1 is half, negative half plus 1 is half. Okay, so we can division of a fraction, we can write it as reciprocal of that fraction, multiplication reciprocal. So this is 2 over 3 u to the 3 over 2 minus 2, reciprocal of half is 2, so 2 times u to the half plus c. Now replace u. Well, what is u really? X plus 1. All right, so 2 over 3 x plus 1 to the 3 over 2 power minus 2 x plus 1 half plus a. Now this is the solution for that integral. Now you want to do this problem again by yourself, convince yourself. Okay, now in the next video, since this video is a little bit long, in the next video I'm going to solve more problems, really tricky problems like this, I promise, in the next video. Okay, so but do this problem by yourself couple of times to convince you. So I'll catch you there. Bye bye.